Good morning, geometry. Today we're going to go through lesson 3 of our circles unit, which is what is a radian. So you, up until this point, have always expressed measures of angles in degrees. Now, there is another way to measure an angle. It's the same thing, it's just a different kind of number, and it's called a radian. So what a radian is it's a unit of angle, so however large this angle is, equal to the angle at the center of a circle whose arc is equal in length to the radius. So here's an example of that. When the arc length and the radius are the same, a radian is how big is that angle, okay? So what we're going to be doing is we're going to be converting between degrees and radians, going both ways. What we need to know first is how many radians would be all the way around a circle. So let's say we're using this example. All the way around my circle. That would be the same as the circumference of my circle. The formula for circumference is 2 times pi times the radius. Now, in our example right here, my radius is 1. So 2 times pi times 1 is just going to give me 2 pi. We are going to leave our answer here in terms of pi. So all the way around my circle, when the radius is 1, would be 2 pi. Okay, now how many degrees is in one revolution of a circle? Degrees, we should hopefully know this, all the way around my circle is 360 degrees. Okay, so comparing these two things, one revolution around the circle is 2 pi radians, which is equal to 360 degrees. Okay, now we're going to make those numbers a little bit smaller just so that they are easier to work with. If I divide both of these by 2, 2 pi divided by 2 is just going to give me pi radians would be equal to 180 degrees. Okay, so that's just going to make our life a little bit easier as we are converting between. So how do I do this? What am I going to do in order to convert from degrees to radians? Okay, so here's what we're going to do. If you are trying to find the radians, what we're going to do is we're going to take our degrees and we are going to multiply it by, I have this conversion factor, so we're going to multiply it by pi over 180. Okay, now if I'm going the other way, if I already have my angle in radians and I'm going to degrees, I'm just basically going to switch these two. So degrees equals radians. Now, instead of times pi over 180, I'm going to multiply by the reciprocal, so 180 over pi, okay? So these are the two equations that we're going to use in order to convert between degrees and radians. Depending on which way you're going, if I'm trying to find radians, I'm going to multiply times pi over 180. If I'm trying to find degrees, I'm going to multiply by 180 over pi. So let's look at some examples of how I do. Okay, I'm going to keep my equations up here just so that we don't have to, or I don't have to keep kind of flipping and showing those back and forth. So let's say that I am given 90 degrees. Okay, my picture of that would be a quarter of the way around my circle. I'm going to use the box because it's a right angle. Okay, so I'm converting to radians. So I'm going to use this equation right here. Okay, so I'm going to take my degrees and multiply it times pi over 180. So I have 90. Now, I'm about to multiply this by a fraction, so I'm going to write this as a fraction as well. 90 over 1 times pi over 180. Okay, now in order for me to multiply fractions together, I just multiply across the top and multiply across the bottom. So 90 times pi, I'm just going to leave that as 90 pi, over 1 times 180 is going to give me 180. Okay, now I'm going to leave the pi, so I'm going to basically ignore it for now. It's going to be in my final answer, and that's okay. But this part right here, the fraction 90 over 180, I do want to simplify that if I can. Okay, so really easy way to simplify. I know we've gone over this before, but in my calculator, if I have 90 over 180, my calculator gives me the decimal, okay? Math, enter will give you the fraction, okay? So this is going to actually be 1 pi over 2, Okay, now usually if I have a 1 in front of my pi, I don't write that. So it would just be pi over 2. Okay, so when I'm going from degrees to radians, I multiply by pi over 180, and then I simplify as much as I can. So in radians, 90 degrees would be pi over 2 radians. Okay, now next one, we're going the other way. We're going from radians to degrees. So we'll use our other equation. We'll take my radians. Again, I'm about to multiply this by a fraction, so I'm going to put this over 1 since it's not already a fraction, times 180 over pi. Okay, so when I multiply across the top, I'm again going to leave pi in my number, so 180 pi over 1 times pi would just give me pi. All right, so if I have pi in the numerator and in the denominator, those are going to end up canceling each other out, and all I'll be left with is 180 degrees. Okay, we did talk about this on the front, that pi and 180 are equal. So if I have pi radians, that's equal to 180 degrees, which is halfway around my circle. All right, so I'm just going to continue on using those same 2 equations. I'm going to move them just because I need more room, but let's go ahead and let's do the next one. So we have 270 degrees, okay? I'm going to multiply that times pi over 180, okay? Again, 270 pi over 180, and then all I have to do is simplify the fraction part right here. So 270 over 180, math, enter, enter, is going to give me 3 over 2. So 270 pi over 180 simplifies to 3 pi over 2. And that would be my final answer. Okay, so 270 degrees, this is 3/4 of the way around my circle. So it would be this entire section right here. All right, and then 2 pi. We're going the other way, so I flip my conversion factor, so it would be times 180 over pi. Okay, so 2 pi times 180 is going to give me 360 pi over 1 times pi gives me pi. Pi's cancel out, and I just get 360 degrees. Again, we talked about that on the front of the notes, that 2 pi and 360 were equal to all the way around the circle. So 360 degrees is my full circle. 2 pi is my full circle. All right, we're going to get into the next few. So 30 degrees, if I'm changing this to radians, 30 over 1 times pi over 180 gives me 30 pi over 180, which simplifies to 30 over 180, math, enter, enter, 1 over 6. Again, we don't usually put the 1 in front of pi. You can if you want to. But it would just be pi over 6. 30 degrees, let's see, for our picture would be, I don't know, about that big. It doesn't have to be perfect. But so like if 1/4 of it's 90, then that would be 1/3 of that. All right, pi over 4, let's convert this to degrees. Now, this one is already in a fraction. So pi over 4, I don't need to put it over 1 like I did for the other 2 because it's already a fraction. I'm going to multiply that by 180 over pi. That's going to give me 180 pi over 4 pi. Pi's will cancel out, and all I have to figure out is 180 divided by 4, you can do it in your calculator, is 45 degrees. Okay, so that would be about half of 90, so approximately that big around my circle. Okay, I'm going to breeze through the next 2, so if you want to pause your video and try them yourself, and then you can see my answers, you can do that, or you can just work along with me. For the next one, 60 over 1 times pi over 180 gives me 60 pi over 180, which 60 over 180 simplified is going to give me 1/3. So this would be pi over 3. 60 degrees would be a little bit less than 90, so about that big in my circle. And then the last one, 2 pi over 3. This is already a fraction, so I'm going to just take that and multiply it by 180 over pi. The pi's are going to end up canceling out, so I'm not even going to worry about them right now. Just cancel them out to begin with. It would be 360 over 3, which is 120 degrees. Okay, which would be slightly larger than 90. Again, does not have to be perfect. About that big in my circle. Okay, now this last question, there is one similar to this in your practice, so I want to make sure to go over one like this. It says that central angle ABC has a radian measure of 3 pi over 4. The area of this sector is what fraction of the area of the circle? Okay, so at the end, our answer is going to end up being a fraction of the total circle. Okay, so if it has a radian measure of this, the first thing that I'm going to suggest we do is convert to degrees. Okay, so 3 pi over 4, if I want to convert that to degrees, I'm going to multiply it by 180 over pi. Okay, my pi's are going to end up canceling out eventually, so I'm just going to do it right now so I don't have to worry about it later. So 3 times 180 divided by 4, this is going to give me 135 degrees. Okay, so it's talking about the area of the sector, but I don't know what the radius is of this circle. Now, it doesn't matter because the area of a sector out of the total area of the circle would be the same as the degrees out of the total degrees, okay? So if I want to figure out what fraction of the total circle, all I need to do is take my 135 degrees out of the total circle, which is 360, and then I just need to simplify this, okay? So 135 out of 360 simplifies to 3 out of 8, okay? So even though it's talking about sector area, it would be the same fraction of the total area as the degrees out of the total degrees, okay? So convert it to degrees, and then we just have to simplify that fraction out of 360.